Welcome back. In this session, we're going to talk about some basic query components. Specifically, we're going to talk about the components of the select statement, which specifically the ones we're going to cover there are select, from, where, and order by. And we're going to talk about some of the things that you can put in search conditions in your where clause, and some of the arguments that you can use in a select clause. And we'll finish up today by talking about null comparisons, comparing columns and constants against null values. Let's start looking at some of the components of a basic select statement. Now there's four parts that we're going to talk about here in this first session. It's the select, the from, the where, and the order by. The select clause of the select statement, I'm going to differentiate between these two. Select statement is the term that I'm going to use to describe the entire query, all of the components of the query, a select, a from, a where, an order by. The other things that we'll talk about later, group by, having, I'm going to all those together when they're put together and run on SQL Server. That's what I'm going to call a select statement. Now, the very first line in a typically, I better be clear. Typically, the first line in a select statement is the select clause. And I'm going to use those two terms, the select clause, to indicate that section of the select statement that defines, as you see here, what you want to see. That's what I'm going to call the select clause of the select statement. And in that select clause, you list out column names or functions or other arithmetic functions that define what it is that you want to see, the columns that you want returned and the data that you want returned from your statement. The from clause in the select statement indicates to SQL Server where the data is coming from. Here you're going to put either the name of a table, the name of a view, the name of a table valued function, or a derived table. That's going to help SQL Server know where to go to get your data from, where it's being stored. The where clause acts as a filter. It tells SQL Server the rows that you want back. This is where you put criteria limiting the number of rows that you want returned and helping SQL Server understand which ones you want. So backing up for just a second, the select is going to give you the columns that you want returned, and the where is going to give you the rows that you want returned, and the from is going to tell SQL Server where to go to get that data. The order by statement is the fourth clause that we're going to talk about, and the order by indicates to SQL Server what order the rows should be returned in, how they should be sorted. And one thing that I'm going to come back to time and time again, both in this presentation and in other presentations throughout this series, is that when you write a select statement, when you send a select statement to SQL Server, if you don't give it an order by, if you don't tell SQL Server how you want it ordered, there's no guarantee that the rows will come back in any particular order. It may be that every time you run your query, the rows always come back in the order that's perfect how you want. But unless you actually put an order by in, you can't be guaranteed that it won't change. Whether the data on your disk changes where it's being stored, or a service pack changes slightly the way that SQL Server analyzes the data. Without the order by, you cannot be guaranteed. It's not guaranteed that the data will come back in any particular order. What I've noticed is that it's usually fairly consistent, and as long as you're not changing the data in the database and where it's located, it comes back consistently without an order by. But even that's not guaranteed. You could technically run the same query back to back to back and have the data come back in a different order every time if you don't specify the order by. Okay, let's take a look at a quick demo using these four components of the basic select statement, these four clauses. All right, the first one I'm going to do here is just a very simple select. And here's a select. It has an example of a select clause, or the select statement. And this select clause has no from, no where, no order by. So it's just this. And that actually runs. It works fine. This is about the smallest select statement you could have, is a select bringing back a constant. All right, but that's not very interesting. SQL Server has only returned what we had. It didn't have to go to any data tables or go to any of the data storage to get our information. Let's actually get some information about the products that we have. And to do that, we're going to add a from clause. And we tell SQL Server to get the data from a table called production.product. So let's go ahead and see what data we have in here. Okay, so now we have quite a bit more data than we had in that first query. We have a product ID, name of a product, product number, the make flag and finished goods flag, what color it is, the safety stock level. We've got all of this information. In fact, we have to scroll over here to get to see the rest of the data that's in this table. And you can see up here in my select what I've told SQL Server. I've provided a star, the asterisk. When you provide that as part of your select clause for a select statement, SQL Server will return all of the rows that are available from the sources that are listed in your from. So in this case, we're getting all of the columns out of the production.product table. And indeed, we got quite a few. This gave us all of the rows and all of the columns, and since we had no where clause, it gave us all of the rows. But what if we didn't want to see all of our products? We only want to see the products that have a particular color. Well, we can do that by adding a where clause. By doing this, we can now see that the results that we get back are all of the red products. You can see down here in the corner that I have 38 rows. If I go back, what I'm going to do is I'm going to comment out the where clause and run this again. We have 504 total rows. So that where clause restricted a lot of the rows coming back, indicating we only wanted the ones that had a color, and that color had to be red. Now, one thing I haven't mentioned before, and I just realized that I'm doing it naturally, but I need to explain what I'm doing. When I'm executing a script, I'm actually hitting the F5 button on my keyboard. F5 by default in Management Studio is the execute, and it will execute whatever you either have highlighted on the screen, or if you don't have anything highlighted, it'll highlight everything that's in the window. Alternatively, you could hit the button here for execute. You can actually see when I hover over it that it's showing me that F5 is the shortcut. Okay, now let's say that we're going to go back to our red products, and this is great. We're getting all of the red products, but what we really wanted to see was which ones had the highest and lowest list price. So we can add that with an order by. And what we're going to order by is this column here, the list price column. Now you can see that it sorted the list price for us. So we have the smallest ones at the top, and they slowly get bigger as we go down until we get to the very bottom. And the very last one here is our one with our largest list price. Now, if I wanted the largest list price to be at the top, I could tell it to sort descending using the DESC after the name of the column. And now the most expensive ones are at the top. Now you can see that there are 5 that had the exact same list price. Within this result, within these five might be returned in any particular order. Right now I have the road 150 red 62 came at the top, and then the 44, then the 48, then the 52. But it might be that the next time I run it, these 5 will still be at the top if my data hasn't changed. But that these 5, since they all have the same list price, they might come back in a different order each time. Maybe I'll get the 44 next, and then the 52, and then the 62. And the next time I run it, it might be in yet a third different order. If I want to sort within the list price, to have an ordering of what the highest list price first, and when the list price is the same, I want it sorted by name, I can add that as another criteria to my order by. I use a comma, and then the name of the column. By default, it sorts in ascending order, but I'm going to go ahead and specify ascending, even though that's still the default. I can actually call it out as well. This time I'm going to click the execute button. And now you can see that within each list price, they're sorted by the name of the product. So these first 5 here are my $3,000 list price, and then I look at my next 4. Those are my $2,400 list price, and they're sorted in order by name as well within that group. Okay, let's go back to our slides. All right, a couple things I want to point out. The tables and column names can be aliased. Now what I mean by alias is the part that you see here in the example underneath the bullet point. You can see that what I've done with the accounts table here is I have the letter A following it. That is an alias. Instead of using the name accounts everywhere in my query, now I can just use the letter A. And you can actually see that I've done that here I specify that the account number column is coming out of the table A, or the accounts table, and so is the name. Now, my personal feeling, and I have a slide at the end that kind of pulls this out, although you can alias tables, my preference is not to alias tables unless I have to. And the places where I have to alias tables are when I'm using the same table name twice in the same query. The reason I don't like to alias tables is for the reason you can see here. A.account number, A.name doesn't mean much to me. I can't tell really where that's coming from unless I look down in the from clause and see what the table A is. Oh, that's the accounts table. So I'm getting the account number of the accounts table and the name out of the accounts table. When you have a from clause with more than one table in it, which we'll do in our next session when we talk about joins, it can become very confusing to have arbitrary names for our tables. We have to go look them up. My preference is not to alias your table names unless you actually have to. Now, another thing that I've done here is I've actually aliased a column name. You can see here that after the A.name I have the word as and then customer name. What this will do is it'll change the name of the column that comes back, and it's really just the header portion at the top of the grid, and it's the metadata that's passed back to an application. It's saying instead of using instead of naming this column name, give it the name of customer name. This is a name that's going to be much more descriptive for the people who are using the data, and it's going to be a lot clearer what's going on. I am in favor of aliasing columns when you need to, particularly when you have several column names that have the same name. You need to differentiate them. All right, the other piece that I want to talk about here are four-part table names. Every object in the database has a multiple part name. For tables and views and the other data sources that we're going to use in our from clause, they have four-part names. There's the name of the table, the name of the schema, the name of the database, and the name of the server. Now, you remember from our demo that we were looking at the production.product table. Production is the name of the schema that our data was in, and product is the name of the table. A schema is an object that lives inside of a database, and it's basically just a bucket, a collection bin, a drawer, a box, well, whatever you want to imagine it as, that contains other objects. So in this case, the production, being our schema, is going to hold all of the objects that deal with production, the making of objects. So product is something that's produced, so that table is placed in the production schema. We could also have other views that are associated with production in that bucket, and we could also have stored procedures or functions, other database objects that are associated with production put into that schema. And a schema is really just an organization tool to help you keep objects together kind of visually and conceptually that belong together. It also helps with permissions. You can assign permissions to a schema, and all those permissions flow down to all the objects in the schema as well. We're going to talk about permissions later, so I'm not going to get that into too much detail here, but recognize that every table that you access has a schema with it. In our case, we use the product table inside the production schema. Now, what you didn't see as part of the query was the database. Each of our schemas reside inside of a database. In this case, we're in AdventureWorks 2012 database. And every database resides on a server. In this case, this is the default server on my box, and so it's just the name of my box, C. Crawford 8. Now, in our query, you notice that we didn't provide all four parts. We only provided the schema and table name. The reason is that SQL Server will make some assumptions based on your query. If you don't provide the name of the server, SQL Server will assume that the object that you're using is residing on the server that you're connected to. Now, times when this isn't going to be the case is when you're connecting to another database instance, another SQL Server or other type of database that's off your instance. And in that case, you create a link server connection to it, and then you would need to provide the server name so SQL Server would know where to go to access that. That's an administration topic that we won't get into in this training series. But if you want to go look up link server, you can actually get some documentation on how that works and when you might want to use the server name. The database name we didn't use as well, and if you don't provide a database name, SQL Server assumes that the object is inside the database that you're currently connected to. If you wanted to query a table that was in another database, you could provide the database name, the schema name, and the table name, and select data from another database outside the one that you're currently connected to. In our case, we only provided the schema and table names, so SQL Server assumed that the table was in the AdventureWorks 2012 database. If we wanted to access a table that was only in the AdventureWorks 2008 database, we would need to provide the database name, and if we didn't, SQL Server wouldn't be able to find the table and it would throw an error. Now in our case, we provided the schema because the 2012 AdventureWorks database has several schemas. Microsoft has organized a lot of their objects into schemas. If you don't provide a schema, SQL Server will follow the procedure you see down here below in this sub-bullet point. It'll look in your default schema first. Every user has a default schema, and it will check there to see if there happens to be a table with that name inside your default schema. So if I had gone into my account and set up production as my default schema, I could have just done select star from product. It would have checked the production schema to see if there's a table in there, and it would have found it, and then it would have returned the data. If it can't find the table that you're looking for, or the object you're looking for in your default schema, then it will go check the DBO schema. And what you'll find in a lot of cases is that when you create a new user, the DBO schema is the default schema. So it's most often the case that it just checks the DBO schema. But if you have a different default schema, it'll check that one first. So the process is check your default schema, then check the DBO schema, and if it's not in either one of those, it doesn't go anywhere to look for it. It doesn't start looking through other schemas in the database to try to find it. It'll actually just throw an error, tell you I can't find this table, and what will happen after that is you'll go, oh, head slap, yes, I need to put the schema name in it, you'll type it out, and away you'll go. For the queries that we're going to run against the AdventureWorks database, you'll find that that all of them have a schema, and so we're going to be using the two-part table names quite frequently through all of our examples. All right, we put a where clause in our query. Let's talk about some of the things that can go in there. I'm going to start in this middle column rather than going left to right. You'll remember that the first thing that we did was we had an equal sign in our where clause. We put where color equals red. That's one type of comparison that you can do, where a column or a constant is equal to another column or another constant. In this case, we did a column equals a constant. Color, the column, equals red, the constant. We can also do greater than and less than. And these do what you would normally anticipate they would do, is looking for values that are higher or lower. Those work with numeric values and with character values. It'll look for things that are further down in the alphabet than red, or closer up in the alphabet than red, if we had used one of those. We can also use an exclamation mark, which is sometimes called a bang or a not. This is used in conjunction with the equals or the less than or greater than to negate it. We're looking for colors that are not red. Exclamation point equals red. Or not greater than 5. Exclamation point greater than 5. So this will give us everything but what we have indicated in our where clause. Okay. We can also do a like, and we're going to look at an example of a like in just a minute, so I'm not going to go into too much detail here because it'll be easier to see how it works than to explain it. But a like essentially allows us to do some very basic pattern matching with our comparison. We also have a between, and I have another slide where I talk specifically about between and why I think you need to be very cautious using between. But between will allow us to look for a value between two others. So I'm looking for products where the list price is between $100 and $200. And we can put that into a single statement using the between. All right, the last one in our comparison column here is an in. In allows us to give a list that we are looking for. We could have done in our previous query where our color is in and then listed out the colors that we're interested in: red, black, blue, green, and yellow. It would ignore all the other colors, but it would bring back any of the products that had one of those colors. And the in allows us to provide that list to SQL Server. All right, conjunctions. In our query that we had in our example, we were looking for products where the color was red. If we wanted to add another criteria to it, we could have used an and or an or. This would have linked those two pieces of criteria together. We want products where the color is red and the list price is greater than $100. We want to find the products where the color is black or the color is green. And we can actually chain different parts or different filters together to create the exact result that we're looking for. Now I have another slide on this as well, but I want to bring it out here. When you put or into your where clause, my suggestion is that you always use parentheses around, you start using parentheses around your clauses so that they're grouped together in an appropriate fashion. If not, it's very possible you'll find out that SQL Server may execute your filters in a different order than you expect, and the or may not be executed where you want, and you'll get either more or less data than you expected. Now we also have a not, and we can put this in front of, I added it here to the conjunctions column. Really what it does is it goes in front of a comparison. And what you'll see is something like where color equals red and not list price greater than $50. So the not here is working quite a bit like the exclamation mark, but the not goes in front of that portion of the clause rather than in between the two items that are being compared. Now we have another session where we're going to talk about subqueries, so I'm not going to go a lot in depth here, but I wanted you to know that these are other options that can go in the where clause. There's another in this case you're passing in, instead of a list of items, you're passing in a query that actually goes out and looks for the list that should be there. And then there is an all or a sum and an any. And we'll get into this a little more when we actually get into the section where we talk about subqueries and derived tables. All right, let's go look at another example using some of these fancier comparisons. Okay, for this example, I've actually written out a little bit of description of what it is that we're looking for, so that we can actually try to get this like you would maybe in the real world. Let's expand it a little bigger. All right, so let's imagine that someone comes up to us and says, look, I need a query. I need to get all the information about employees who have at least 50 vacation hours left, and what I need back is their national ID number, their job title, their hire date, and their vacation hours. And I'm really interested in the ones where I need them ordered by their hire date. I want the people who were most recently hired at the top of the list. Okay, well, let's write this query. First thing we do is we're going to look to see where our data is, and we find that our data is in the human resources schema, and it's in the employee table. So let's take a look at this. Here I'm going to highlight and hit F5 again, and here's our data. So we've got quite a bit of data here, a few columns, a lot of data. All right, so we've found our information. There's a national ID number and job title, and it's got the hire date, and it's got vacation hours. Okay, now we're looking for the ones who have at least 50 vacation hours remaining. So that's going to go into our where clause, because we want to filter the rows. We want to reduce the number of rows so that we only get the ones that have a lot of vacation hours. Now they said at least, so 50 is included, so we want to do greater than or equal to in this case. Now we started out with, if you look down here, 290 rows. And then we run this one. Now we're down to 150 rows. Okay, so these are the employees with at least 50 vacation hours remaining. Now we want to order by their hire date. And we want the most recent hire date listed first. Now when we order by hire date, and we order by a date, it's the default is going to be ascending, and ascending would list the oldest ones first and the newest ones last. So we actually want this to come back in a backwards order. We also only needed the national ID number, job title, and hire date, and vacation hours. I'm going to cheat here since somebody very conveniently listed the requirements using the same as our column names. All I need to do here is put a comma in between. Okay, and here is our query that we can give back to whoever it is that came and said, I want this list. Here's our list. It has the columns that they've asked for, sorted by the hire date, and it only contains the 150 who have vacation hours in excess of 50. Okay, So there we go. There's a query that used all of our 4 clauses that we've talked about so far. Select from, where, and order by. All right, here's our second one that we need to do. Let's give us some space here. Write a query that returns the business entity ID, first name, last name for all persons whose last name starts with CO. Okay, so persons, that is in the persons schema. And it's in the person table. So let's take a look at the data we have there. All right, we're looking for business entity ID, which is the primary key. We've got that. First name and last name. Okay, so let's put our columns in. Again, thankfully, they gave us exactly the ones we needed. And we just need to change the and here to a comma. And then they want the ones where the last name starts with CO. Okay, there's a couple ways to do this. The way we're going to do it is we're going to use the like. The like, again, as I mentioned before, gives us some pattern matching. What we're going to do here is we're going to say that it has to start with CO, and then the percent sign is a special character. It's a wildcard character that tells SQL Server to look for any number of characters, including 0 as a number of characters, and any type of character. So this query here will return rows where the last name begins with CO, and then it has 0, 1 or more characters after that. It doesn't matter what the characters are. So if we run this query here, we get Cobb, Kaufman, Cole, Coleman. You can see that all of these last names, as I spin down through this list, all start with CO, all the way down to Cox. Now, interesting enough, here you see that it seems to be sorted by last name as well. CLX, S, R. As we scroll up, this last name, it seems to be sorted by last name. This is a function of how SQL Server decided to run the query against the data and the way that the data was inserted into the table originally. So in our case here, getting the information back sorted by last name was a lucky piece of chance. If we wanted it always to be returned in alphabetical order by last name, we would need to add an order by. And again, this is the second time I'm going to say it, and I think I've got maybe twice more that I'll do it today. If you don't put an order by in, there's no guarantee that the data will come back in any specific order. All right, let's go look at our third query that they've asked for here. Okay, list the product ID, name, and product number for all products that are red with a list price greater than 500 and an inventory of at least 100 units. Okay, this is very similar to the one we did in our previous demo. In fact, let's go ahead and start. Okay, our product, and they want the ones where they're red. We know how to do that. And we know how to add another piece of criteria here because we talked about it in the slides. We use our and. Going on to the list price greater than 500. Okay, let's take a look at this one real quick. Okay, so now we got our red and our list price greater than 500. We're down to 31 rows. And the last piece that we need to do here, actually, let's get our columns set up first. Oops. Take out my and. Thank you, whoever mentioned that. Ah, and I need to take out the space. Little red squiggly lines are telling me you're going to mess up your demo. All right, here we go. So here's our 31 rows and the columns that we want. The last thing we need is an inventory of at least 100 units. Now I'm going to add another column here at the end. I'm going to add the star so that I can see all of the columns in the table, so I can find the name of the inventory column. When I look out here, I see the safety stock level and reorder point, but I'm not seeing anything dealing with inventory. And the reason that I don't see anything dealing with inventory is our inventory is not in this table. Oh, okay. Well, let's go look and see where that inventory data is. It's somewhere else. It happens to be still in our production schema. It's right here in our product inventory. So when I look at this query, I can see that this is where my inventory is. So I have a product and a location, shelf and bin, and then a quantity. So for product 1, it exists in these 3 places. Product 2 exists in these 3. And I have all my products in here. Okay, well, we're looking for products that have an inventory of at least 100. Quantity greater than 100. For the purposes of this query, I'm going to assume that when they say inventory of at least 100 units, they mean in a particular bin and a particular location. So here's a list of all of my products that have a quantity of at least 100. Well, that's 883 of those. That's quite a few. As I look down through here, I can see there's a lot of product IDs here. How do I restrict my first query based on this one? Let's run them both together and I'll show you what I'm trying to say here. So here I have these products that are red and greater than $500, and here I have these products that have inventory over 100. How do I bring these two together? Well, I can do that using an in. All I have to do here is do and product ID in, and then I list out the product IDs that have a product of at least, or have at least 100 in inventory. Well, I can start here for 50, 51, 452. If I scroll down, I can see there's a 750. I can just keep going, but I'm going to have to type in quite a few rows here. But it would work. If I select here, oh look, so far I found 3, but there were 800 that I need to type in. That's quite a few. It's going to take me a long time to type those in, and that'll create another problem. When I run this query, if inventory is changed, I have to go back through and look and type in 800 more, figure out which ones have changed. Maybe there's more inventory now, and so instead of typing 800 numbers, I've got to type in 1,000 or 2,000 numbers because our inventory is really high. Well, I don't want to have to go in and do that every single time. And in our next session, we're going to talk about the join, and we'll show you then how you could write this query even more simply, and we'll cover that then. There's one other piece that I want to do here before we go back to our slides, and I want to give a little bit of an example of how some of the like statements can be used. First thing I'm going to do is I'm going to add a row to our person table. You can see here that the row that I'm adding is for a Chadwicksworth Crawford, and when we go look at the table, we can see, if I scroll here to the bottom, we can see the data we've added here, Chadwicksworth Crawford. For some reason, this poor soul has brackets in as actually part of their first name. Just for the record, no, my name is Chad. It's not Chadwick, nor is it Chadwicksworth, nor does it have any brackets. But this is a good example for us to use to actually bring out this part of the like functionality. Well, this first query that I'm going to use here is going to do a select with a like, similar to what we did in our previous example. I'm looking for first names that start with Chadwick, and then have the % sign here as our wildcard character. So any number of characters and any characters after that. But when we execute it, we actually don't get any rows back. Why is that? Well, the reason is that the bracket is also a special character for a like statement. And so instead of looking for, and what the brackets do is the brackets give a set of characters that should fall in that place. So what this has done is it's looking for first names that start with Chad, and then follow with the characters W, I, C, or K. So looking for Chad W, Chad I, Chad C, Chad K, and then followed by any number of characters and any characters after that. Since the name that we actually have in the database doesn't have a W after Chad, it has a bracket, it won't actually find the row that looks exactly like the one that we picked. In order to find this row, we need to tell SQL Server that when we put this bracket in, we're not trying to specify a group of characters. We're not looking for Chad W, Chad I, Chad C, and Chad K. We're looking for Chad bracket. This bracket is no longer a special character. We want it to actually be a character that's part of our search string. We do that using an escape. Here, the line below, I've added the word escape and then a pipe in single quotes. What that tells SQL Server is that for the like that immediately precedes this escape statement, the pipe is going to tell us which characters are no longer special. So here we had Chad, pipe, open bracket. That turns off the open bracket and says instead of now using the open bracket as a special character that begins a set that we're looking for, the open bracket is now the character we're actually looking for. The close bracket's another special character, so we need to put a pipe in front of it to turn it off as a special character as well. So when I highlight this section and run it, I can actually get back the one that I'm looking for. Now the percent here is still a special character because we didn't put a pipe in front of it. If we did put a pipe in front of the percent, it would be looking for first names that had Chad, and then an open bracket, then a wick, then a close bracket, then a percent, where a percent was actually inside the string. Since that doesn't match, of course we're not going to get any rows back. Okay, let's go back to our slides. Make sure that when you're using your where clause, you watch out for case sensitivity. This is something that you're going to have to look for in actually all of your clauses, but it's going to probably get you, surprise you the most in your where clause. When you create a database, it can be created either case sensitive or case insensitive. Now when you restore a database or you attach a database, the database already has a case sensitivity setting. When you create one, it's going to be created with a specific case sensitivity. If your database is case sensitive, the names of your tables are going to be case sensitive, and the values inside your columns will be case sensitive as well. That means that if you type production.product all in lowercase, it's going to look for tables that have a schema and a table name that are in all lowercase, and it won't find it if the P in production or the P in product is uppercase and you typed it lowercase. Also, in this case, if you're looking for colors that are red and you type in red in all lowercase and your database is case sensitive and that column is case sensitive, then it will look for a lowercase red, and any of the uppercase R reds won't be returned. Now you can change case sensitivity on a column by column basis by using a collation, and we're going to talk about collations later, so I'm not going to go into it here. But be aware that as part of the where clause, you need to make sure that you understand the case sensitivity of your database. In all of our examples, we're using a case insensitive AdventureWorks database. And so for our queries, if we typed uppercase red or lowercase red, it would still return red no matter how it was cased in the database. Now I told you that I had a caution for using between. And that caution is that the between is inclusive on both ends. So if you're looking for all of the dates between January 1st, 2012 and January 1st, 2013, any of the dates that are exactly January 1st and 2012 or exactly January 1st, 2013 will be included as well. Another example would be if you're looking for any products that have a list price between $100 and $200, the products that are exactly 100 and exactly 200 will both be included in your queries. Now I have a note here that says that's not typically what you want, and I really it's very seldom that is what you want. Typically when you're using a between, it's because you're trying to segregate your data into pieces. We're trying to separate it by years. I only want 1 year's worth of data, or I only want $100 worth of products. I want the $100 to $200, and then I'm going to query again later for the 200 to 300 and later for 300 to 400. I'm looking to break them into groups. Between won't accurately break them into groups for you in most cases. The reason is that those partition values, the $100 and the $200, will fall into both the lower bucket and the upper bucket. So when you run a query for the list price between $100 and $200, the $200 one will be in there. When you run the query again for $200 to $300, the $200 one will be in there as well. And that's probably not what you were looking for. You see this again on dates. If you're looking for orders placed between January 1st, 2012 and January 1st, 2013, and then you run another query to get the ones between January 1st, 2013 and January 1st, 2014, if you happen to have an order that's exactly January 1st, 2013, it'll show up in both results. And that's not going to be what you want. Now I said in most cases it will return both ways, and the reason I say in most cases, if you put your partition between two values, and you know that the partition, that value can't exist, then you'd be safe. But that's typically not what's going to happen, and that's not usually the way you set up your data. What I found is usually when I use a between, typically when I use a between, I'm using it incorrectly. And what I end up doing is going back and rewriting it to be a greater than one value and less than another. Actually, let me rephrase that. Greater than or equal to the lower bound value and less than the upper bound value. That allows you to have a very clean division with no overlaps in your where clause. I mentioned it once, but it bears mentioning again. If you're using an or in your where clause, always use parens around it. If you're using an in and you pass in a list, in our case, where if you have a list where you're looking for where the color is in red, comma blue, comma black, comma green, that's really the same to SQL Server as if you had done where color equals red, or color equals blue, or color equals black, or color equals green. SQL Server actually will take the in and internally execute it the same as it would as if you had a bunch of ors. So it's really shorthand. It keeps it cleaner. It's nicer to, it's easier to write and it's nicer to look at, but it has actually the same functionalities if you use an or. Here I've listed the special characters for the like. We talked about the escape, and here I have a pipe in here. You can use any character at all that you want for the escape character, but recognize that as soon as you put it in, that's a character you can't use inside of your query string. I like to use pipe because the pipe is very seldom used as part of a string unless you have a comma limited list of some kind in your column. In that case, sometimes those will be pipe delimited. But I like using the pipe because it very seldom shows up in typed strings. We talked about what a percent does inside the like statement. It stands for 0 or more characters and any character. An underscore stands for a single character of any character. So in our previous query where we were using the like, if instead of Chad, I had done CHA and then an underscore in a single quote, that would have found Chad, because Chad, the D is any character and it's only one character. It would have found chat, and it would have found chaw. Let's see, what other words start with CHA and then have another letter after it? It would have found any of those 4-letter words that started with CHA and then had a single letter after it. However, unlike the percent, it wouldn't have allowed more than just one. So Chadwick would not have come back, because even though CHAD matches the pattern, the wick are additional characters after that, and an underscore says I'm looking for a single character. Now you can still work around that by having multiple underscores next to each other, and that will work out fine. But each underscore only what am I trying to say here? Each underscore only represents a single character. All right, we talked briefly about the brackets. The open and closed brackets go together, and wow, that was a really funny arrow there. There we go. The open and closed brackets will allow you to put in a series of characters, any one of which you want to match in a single spot. So this gets a little more specific than an underscore. An underscore allows any character. When you put two brackets and have a set of characters inside, you're defining for a single spot what characters are allowed in there. So in this case, if we had done CHA and then open bracket D and W and then a closed bracket, that would have found Chad and Cha, but it would not have found chat because T was not as part of our list inside the brackets. When you're doing this, you don't put commas between them, you just list all of the characters in there, all in one big clump. The caret is a not character. So putting the not into a like statement says whatever follows this is what I am not looking for, all of the rest of them are valid. All right. Some other arguments that you can put in the select clause. You can do distinct, and these are clauses that are part of the select. So we've moved from the where clause. We're talking a little bit about the select clause now. You can add a distinct, and that will take your result set, and if there are any rows that are exact duplicates of each other, it will remove one and only show you the ones that are unique. This is based on the columns that you're returning, not based on rows out of the table. So if you're returning a column, let's say you're selecting color out of the production.product table, and you say select distinct color from production.product, you'll get a distinct list of colors that are in the table. You get red, blue, black. You get each one only once, regardless of how many times it's in the table. You can also provide, use the keyword top. And the top restricts the number of rows that come back. There's two ways to use it. The first is with a specific value that tells exactly how many rows that you want. And the second is with a value that indicates a percent. So the first one here would return exactly 100 rows, or less if there were less than 100 rows that matched the where clause and that were in the table. The second one says look at the results that come back and return to me 50% of those rows. So this would actually say, okay, we have 100 rows, so we'll return 50. Or we have 200 rows, so we'll return 100. Or we have 36 rows, so we'll return 18. So it'll figure out first how many rows it has, and then it will return a certain percentage of those rows. The next special character we're going to talk about is the star or asterisk. It's the asterisk on the keyboard. In SQL parlance, we call it the star. That means to return all of the available columns from the data sources, the tables, the views, the functions that you've put in your from clause. And we mentioned that a little bit as well. All right, let's visit null again one more time, and we've talked about it. I think this is the third time we've talked about null. Let's talk about null comparisons, since we've talked about comparisons in our where clause. If you have null equals null, that does not evaluate to true. Nor does it evaluate to false. It evaluates to a third that's called unknown. So if you have in your where clause the statement where null equals null, you won't get any rows back because that is never equated to true. If you have where null is not equal to null, that will still not return any rows because that's never true either. In fact, null with any comparison to any other value always comes back as unknown. And this will become important where you build a where clause and you're looking for where color equals null. The color column, even if the data in the column is null, it won't return true and it won't return that row. You'll never get any rows back using a null equals or null not equals comparison. And that's because of a setting called, it's not because of the ANSI null setting. Yeah, it is because of the ANSI null setting. It's not, I was thinking ANSI defaults. So there's a setting called ANSI nulls, and that is by default set to be on. If you go and set that parameter, set this setting to be off, set ANSI nulls off, then nulls can be compared with other nulls. Now you notice here there's a piece here, and if I remember right, I cut this out of the books online, that in the future ANSI nulls will always be on. So don't use set ANSI nulls off as a shortcut to get nulls to evaluate to each other. And I've actually seen this in some stored procedures where people have done that and said, oh, I'm just going to go ahead and turn ANSI nulls off so my nulls become equal to each other. If you do that, you won't be able to upgrade at some point. The use of that's been deprecated, meaning that Microsoft plans to pull that out and will eventually pull that out as SQL Server. So it'd be in your best interest to start redoing that development to compare nulls correctly if you have that in your code. The proper way to use compare with nulls I've had down here at the bottom, where something is null or that thing is not null. So in this case, if we were looking for products that didn't have colors, we would put in our where clause where color is null. And if we were looking for the ones that had a color, it would be where color is not null. And that would correctly compare the null constant that we have here on the right hand side with the column on the left. All right, one last slide here before we go on to the next section. Just a couple things to remember. If you don't need to alias your tables, please don't. Again, that's my personal preference, and it's been great for me, what I've seen through my experience in making sure I can keep track of what's in the query and where it's coming from. If you in your environment have a production standard where they encourage aliases, then go ahead and do it, unless it bothers you as well, and then try to get the standard changed. My preference is not to alias tables unless it's absolutely necessary. Don't use the star or asterisk in a production query. You see me do it here during the demos, And that's fine when you're on a development system or you're working on your own box. But if you use the star asterisk on the production system, you're going to end up using more resources than necessary. And again, this is just when you don't need all that data back. But think of this as well. Let's say you need all of the columns back from the table, so star is appropriate. I'm just going to get them all. What happens if you now add a new column to the table or make a change to the table? That star will bring back all of the columns again. In this case, you may not need all of them anymore. You may not need the new column that's been added. So in my opinion, it's a best practice to not use a star in a production query, to always spell out the columns or the functions that you want returned. And again, here's the third time. Remember that unless you include an order by in your query, there's no guarantee on how the results will be returned. And I think that goes categorically without exception, that there'll never be a guarantee on how the results will be returned unless you have an order by. All right, thank you for sticking with me today. If you have any questions, you're welcome to stop by and ask me in person or send me an email. You're also welcome to reach out to me on Twitter at dbachad. Thank you, and we'll see you in the next session.